This is a short description of the tools that are available in Fijiwings. Fijiwings can be downloaded from its website at sourceforge.net by clicking on the download link, and a zipped file will appear on your desktop. Double-clicking on the zip file expands Fijiwings, and Fijiwings can then be moved to the Applications folder and then launched directly. At SourceForge, you can get several example files for using Fijiwings, and you can open these files using the Open button. I'm going to use this wing micrograph example to go through some of the properties of Fijiwings contained on the action bar. The first feature is the 75 pixel square trichome density tool that, when you click on it, allows you to choose an area of the wing. Click on that, and it will take a 75 square pixel region and count the number of trichomes in that area, reporting that number, and then calculating the density of trichomes in the selected area. The 150 pixel square trichome density tool does the same thing over 150 square pixel area. And finally, the polygon trichome density tool calculates all the trichomes in an area that you select. In this case, I'll select the posterior wing compartment, double-click to close the polygon, press OK, the total number of trichomes is calculated and their density is as well. Finally, a noise adjust button here allows the user to set the noise, where the default noise is set at 10. When you click on the button Segmentation 4 GB RAM, a new action bar appears. That bar breaks down the automated steps and allows slower machines to run segmentation analysis. Step 1 resizes the image. Step 2 launches Weka segmentation, which automatically identifies veins and intervein regions. Step 3 performs particle analysis, sending the data to an ROI file, and presents the wing as a drawing entitled Drawing of Classified Image. Step 4 resizes the image, placing it alongside the original. Intervein trichome density can then be determined by clicking this button, and for this analysis it's important that the original be placed on top. So by clicking this button, a prompt appears asking you to select an intervein region. By selecting the posterior intervein and clicking OK, it calculates the size and trichome density of the region. The data is presented in pixels and trichomes per pixel, respectively. When you click on the button Segmentation 8 GB RAM, a macro resizes your image, launches Weka segmentation, which detects veins and interveins, and then performs particle analysis, sending the data to an ROI file, and finally presents the wing as a drawing. You can perform intervein trichome density analysis after doing this. Or here, we will perform heat map analysis by clicking the Heat Map Interveins button. Fijiwings uses the information in the ROI file to assign a color to the intervein region corresponding to its area in pixels. The Heat Map Trichomes tool allows the user to identify all the trichomes on the wing, to connect the dots, if you will, between trichomes, and then assign an area to each subtended region and apply a color. The heat map that results gives the user an idea of the distribution of trichomes in a particular area. When it's applied to an Engrail Gal4 driving Tribbles wing, you can see the progress going along this bar at the top. It finds the trichomes, identifies an area for each, and then applies a color. Here you can see the trichomes are much more widely distributed, so the color heat map is hot, and the color is cooler, where the normal distribution of trichomes occurs at the top. You can use this button, Heat Map Adjust, for this pop-up box, and choose trichome density as opposed to intervane area, and then play with colors and play with ranges. So I can change this to orange. Hit OK, and it will change accordingly.